You open your banking app. The design is beautiful. Face recognition logs you in. Your balance appears instantly. Everything feels modern. You enter an amount, tap send, and a few seconds later, your friend receives the money. It feels almost effortless. But hidden underneath that beautiful app is a surprising reality. Parts of the banking world still depend on technology designed decades ago. Technology older than smartphones, older than Google, and in some cases, older than the modern internet. So here's the mystery. If banks control some of the most important systems in the world, why haven't they simply replaced the old software? To understand why, let's follow that transfer. Your phone sends a request. It passes through security checks. The bank checks whether the transaction is valid. Fraud detection systems may examine it. Different services communicate with each other. And eventually, the transaction reaches something much deeper. The system that remembers who actually owns what. Deep inside a bank is something often called the core banking system. Think of it as the bank's memory. It keeps track of accounts, balances, transactions, interest, loans, and countless rules about how money is allowed to move. This isn't just another application. If this system gets money wrong, the consequences are very different. Decades ago, banks needed computers that could process enormous numbers of transactions reliably. Mainframes became extremely good at this job, and much of the business logic from that era was written in languages such as COBOL. Today, that sounds ancient. Yet technology with roots in that era can still sit inside critical financial infrastructure. Which raises another question. What if the old system is still very good at its job? In technology, we often assume newer means better. A new phone, a new processor, a new programming language, a new architecture. But banks care about something more boring and far more important. Reliability. A system running for decades has already faced network failures, duplicate requests, reversed payments, strange edge cases, and problems that may have appeared only once in 20 years. The system may not be beautiful, but it has scars. And every scar represents a lesson someone already paid for. A bug discovered, a failure understood, a rule added, a strange exception handled. So why not simply copy all those lessons into a modern system? Imagine the bank decides to rewrite everything. A new team arrives. They choose a modern programming language. They design a clean architecture. They build modern services. And the new system looks better in almost every way. There's just one problem. The old system contains decades of rules. Some rules are documented. Some are hidden inside millions of lines of code. And some exist because decades ago, something strange happened, and somebody added a condition to make sure it never happened again. Remove one of those rules, and maybe nothing happens today, or tomorrow. Then 6 months later, one rare transaction behaves incorrectly. In banking, almost correct is not good enough, and the code is only part of the problem. Imagine trying to replace every railway track in a country, but there's one condition. You cannot stop the trains. Not for a day. Not for an hour. Salaries still need to arrive. Cards still need to work. ATMs still need cash. Businesses still need to make payments. You cannot simply display bank unavailable. Come back next month. The old system must keep working while the new one is being built. So instead of replacing everything in one giant move, modernization is often gradual. New mobile apps are built. Modern APIs connect systems. Cloud services handle selected workloads. New fraud detection systems watch transactions. Analytics platforms process enormous amounts of data. Slowly, a modern technological city grows around the older core. The customer sees the newest layer, but underneath it, the old core may still be doing some of the most critical work. Developers have a name for technology that becomes difficult to change. Technical debt. And old systems can create plenty of it. They can be expensive to maintain. Specialists may become harder to find, changes can take longer, and integration becomes complicated. But here's the paradox. The same system may also contain decades of valuable knowledge, thousands of business rules, years of fixes, strange exceptions, lessons learned the hard way. So the system can be two things at the same time: a liability and an asset. Modernizing a bank isn't one giant software update. It's closer to moving an entire city, one building at a time. While people are still living inside it, one service moves first, then another. Old and new systems may run together. Data must be migrated carefully. Every step is tested, then tested again. Because the real challenge isn't simply building a modern system, it's reaching the new world, without losing trust along the way. Remember the transfer from the beginning? You tapped send. Your banking app showed a small animation. A few seconds later, your friend received the money. You didn't think about APIs, core banking systems, mainframes, old programming languages, migration projects, or decades of hidden business rules. And that's the strange thing about infrastructure. When it works perfectly, nobody notices it exists. Sometimes the systems that look easiest to replace are the ones the world is most afraid to turn off. Old software is easy to laugh at until you realize how much of the modern world still depends on it. And banks are only one example. Behind the technology we use every day are systems most people never see. Subscribe to Debug with Dorjee, and let's discover what else is hiding beneath the screen.